Okay, we're going to do cluster analysis. I've kind of cheated a little bit here because I've already run these. Well, I ran this and then I ran this. So that I could have this stuff in my console. Oops. But I think that's fine because you should know what this does by now. Read Excel using the library, read Excel to get my data, which was here, but then I realized it was all kind of coded into this weird questiony stuff that doesn't make sense. So I made this little matrix of things that label things better. So like this question 9.5 is actually whether or not people have jobs. Cost is whether or not people think cost of enrollment affects, or whether or not people can afford summer enrolling. Cool. And then this one is flexibility. How much do people want flexibility in their classes in summer? I'm going to push that all into data, which is right here. So I just did that so I can talk about it a little bit more. So basically, this data set, I'm going a little out of order here, but basically what we're trying to look at here is students who want to take online classes. I have this idea that students who want to take online classes are going to be the students that work, that have cost concerns, and that want high flexibility in their options for courses. So basically what I'm saying is that I think people who want to take online classes are going to be people who are high in all three of these dimensions: work, cost, and flex that I just described. So I have one of these variables, I believe it's 11.9. We'll see for sure later in the code, but I think 11.9 is the actual, would I want to take online classes or do I like online classes? And those other two variables in here are just artifacts. So I'm going to close that. So yeah, why cluster analysis? Because though I have this idea that people high in all of these variables are going to want to take summer classes, first of all, I don't actually know if it's true. Um, so we can look at that with the data that we have a little bit. But also, even if it is true, there might not be anyone in our student population that is described by that. So we can kind of look at the patterns in students that do respond by putting them into clusters and see kind of where the people that we have, the students that are at tech that could enroll in summer quarter, where they actually fall in these dimensions. Basically with the goal of trying to figure out, is it worth investing in online and trying to cater to people who want online. So that's the research idea. What am I supposed to tell you about? I think that kind of covers why cluster analysis. What similarity index indices are we going to use? I think that is referring to how we're going to determine the number of clusters. And we're going to look at just the gap statistic. I think that's a pretty good thing. I've already kind of looked at these data. You already know that. But the gap statistic, and then we're also just going to run the nuclear method, which I'll go into detail a little bit more about, but just kind of for shits and giggles. Um, and I guess I could say we're specifically not going to look at the knee method because I think it's like pretty hard to interpret. And yeah, I think that the nuclear option is going to give you, if you're going to go for not really easily interpretable data, the nuclear option, which is like based on a bunch of different approaches and kind of looks at which one is, or which methods are how many of each method says which cluster. I think that if you're gonna look at something subjective, that I rather that than the knee elbow knee approach or whatever. But yeah, cool. What clustering approaches are we gonna use? Hierarchical clustering. Cool. We're gonna use Ward method. We'll get into that in a little bit. And validation, like I said, we're gonna look at our clusters. We're gonna see if those people were actually more likely to, or if we come up with a cluster similar, whatever cluster is more similar to what I said, high on all three of these variables. We're going to see if those people were actually more likely to want to take online classes. And then also we're going to look at differences between clusters on these clustering variables to see if they actually factor into like the clustering, what cluster they belong into. Cool. Okay, already ran everything up to here. So let's start with the methods of how we're going to figure out how many clusters we want. So I'm just going to run this gap statistic. It's going to spit out a number. It's going to be like, hey, you should run this many. It's going. Cool. And you can see in the comments, just bootstrap method, 100 bootstraps, maximum 10 clusters, k-means. Cool. Bunch of output comes out. That's cool. This is the only real thing we care about. Looks like 2. That's good. It could be good, depending on how those clusters kind of form. But it could mean that we have a group that wants to take online and a group that doesn't want to take online. That would be ideal, but it might not. And before, what I would do here is I would probably look to see at what those patterns of clusters actually mean, or not what they actually mean, but how the clustering, how basically they went about with making the clusters. But before we do that, I wanted to run the nuclear method just because, hey, why not? Might as well look at a bunch of different indices and see what they all say. It's going to take a little bit, so let me go ahead and go with that. Yeah, okay, it's running. Yeah. So what I was saying before is that 2 clusters could be good for us, but there's no guarantee that those 2 clusters are going to kind of show differences between online or not online. Oh, look, it finished. And it outputted stuff. So, oh, I didn't run everything. Let's run this real quick. I didn't run the thing that pops out this cool graph, but we have some more useless graphs that did pop out, so that's cool. These are just kind of graphs showing from some of the different options that we ran, but this is the one that we're really interested in. That came from this line here. I guess I should be explaining these lines a little bit more. This is not really that hard. It's just saying the Euclidean distance. This is the minimum number of clusters of 2, maximum of 10. Method complete, that just means it's going to do all, or combination of these two means that it's going to do everything it possibly can. And then this is just what makes our graph. Okay, cool. So what this is basically saying is kind of clear that, hey, 4 was probably the best, which is not what we got from our gap statistic result. But what we did get from our gap statistic result was 2. So 8 of them proposed 2. And nothing really gets even close to that. I guess that's why we have this chart here. So 8, 2, 4, 9, 4. Pretty comfortable going with 2. We'll explore 4 just for the hell of it, briefly. Because maybe 2 doesn't end up being as golden as we want it to. And after all, 4 did have one more option that suggested it. So, so we'll look at both, and then we'll see what we see and figure out what we want to go with from there, which I think is okay to do. Not actually sure on that. Pretty sure it is, though. None of this matters anyway. Okay. So let's go with 2 first. So I'm going to make my magic cluster number now that we know for sure that 2 is definitely the best option for the number of clusters we want to do. We're going to go with magical number of 2. Then we're going to go back and do 4. Because then 4 will be definitely the best one. And magical cluster number is kind of long, so I just put it into MCN. Let's run those. Bam. Nope. Bam. Oh. That's not really going to work because I didn't highlight it all the way. Okay, try one more time. Bam. Looks like I was just wrong before. Okay, cool, but it's run. Okay. So now we're going to actually do the cluster analysis. Hierarchical walled, or ward, sorry, not walled. Still thinking of, whatever, that other thing, logistic regression. Hierarchical road method. So what is this doing? This is calculating a distance measure based on Euclidean distance. Then it's going to cluster them based on that distance that it just found. And based on that fit, it's going to plot them into the clusters. It's going to take that kind of like cluster information that's based on the distances, and it's going to look at our magical cluster number and take it, put them. Okay, this is a little bit inaccurate what I just said, but basically it's going to plot the things based on the Euclidean distances, and then in this one, it's going to look at our magical cluster number and identify the clusters, which is going to be 2. It's this here, k equals MCN, and also based on that fit. That's calculated. And it's going to push all that into groups. So it's going to assign all of our people with a cluster number. And then this is for our dendrogram, just to kind of show our clustering space a little bit more clearly. It's going to outline those 2 clusters in red. Okay, cool. Bam. Boom, this is our dendrogram. Let's make it big. Wow. Bam. Ain't that a nice dendrogram? It's nice and simple too. So you have a little bit more people in this cluster than this one. Cool. You can kind of actually see how if we did 4 clusters, we'd end up splitting here and splitting here. Then we'd have kind of this one that has a lot of people and these that have less people. We'll get to it though. All right, by dendrogram, kind of. Yeah, okay. So that's what that did. And now we have this groups thing. So now we just need to validate, see what's going on with these clusters now that we have them. Oh wait, no, we're not going to do that yet, huh? Yeah, we are. Cool, let's do that. I made this matrix here that's valid. It's really similar to our other matrix that we made, data, in that it has the clustering variables, but like I said, we're going to put online, which I'm pulling from the original data set, and then we're also going to put that groups variable, we're going to save it into this matrix so that everyone is assigned groups. So like kind of how it works is that like if I run this, so now you see data. Cool, we can open it in half. Awesome. So like this is like person 1, that's 5s, person 2, person 3, and then you can see invalid. Same pattern of responding for the clustered variables. Oh, I'm about to run out of time. Cool. But same pattern of responding for the clustered variables, and then but you've added the group and online scores to it as well. So 1, 2, 3, and I'm out of time, but we'll be back in another video. where we're going to go into looking at the actual cluster information. So excited.